Standard gravity pulls a dense rock straight to the bottom of a dark pool of water. It is a predictable result of mass and displacement. But there are specific stones found in nature that appear to break this rule. Instead of dropping, this rock rests right on the surface. It bobs with the current, remaining completely buoyant. For a seemingly solid object, this contradicts basic scientific expectations of how heavy minerals interact with water. The mechanics of this localized anomaly point toward a much larger geographical mystery. These specific floating stones are gathered from the coastlines between India and Sri Lanka. Thousands of visitors have witnessed these stones in local temples and museums, where they have been kept in water tanks for decades. According to the Ramayana, an entire 30-mile bridge was constructed across this strait using these floating stones, allowing an army to cross the ocean. Using materials that deviate from normal density to build a massive architectural structure raises immediate physical questions. Cultural tradition provides a location and a purpose for the site, but the physical evidence requires a closer look at the environment itself. To evaluate the site objectively, we have to look past the coastal displays and view the region from orbit. Modern satellite imagery shows a distinct chain of formations stretching between the two landmasses. This 30-mile-long formation follows the exact path described in the ancient accounts. Geologists identify the structure as a natural chain of limestone shoals and sandbanks, shaped by tidal currents and rising sea levels. If the macrostructure is made of limestone sand, the question remains, why do individual stones found nearby actually float? While geology explains the shape of the land bridge, the secret to the buoyancy is found in the microscopic structure of the stones themselves. The physics of the stones is centered on porosity. Under a macro lens, these volcanic rocks reveal a density of microscopic voids. They are filled with thousands of tiny air pockets. When volcanic material erupts and cools instantly, it traps escaping gases. This creates a solid structure that's incredibly light. The volume of internal air offsets the solid mass, resulting in a net upward buoyant force that keeps the stone on the surface. Do you believe this specific type of volcanic porosity explains every floating stone at Ram Setu, or does ancient engineering play a part? Let us know in the comments. Material science provides a functional mechanism for the anomaly, moving the discussion from the miraculous to the physical properties of the Earth. We now have two distinct explanations for the same 30-mile stretch of ocean. Today, Ram Setu remains a rare intersection of geology and faith, where modern boats gather over ancient shoals. The stones follow strict physical laws of density. Yet, the existence of this distinctive geological formation at this specific historical strait remains a notable event. A natural explanation for the stones does not diminish the long-standing cultural weight of the site. Both perspectives independently validate its importance. The focus shifts from the composition of the rocks to the cultural impact of the site itself. As centuries pass and the ocean continues to shape the coastline, the interest in this formation remains unchanged. It raises the question of why certain ancient mysteries continue to command attention thousands of years after they were first recorded. If you enjoyed this investigation, please like the video and subscribe to Untold Indian Stories. Every week, we look at forgotten history, ancient mysteries, and true stories from across the globe. Keep questioning the impossible.